Hello, everyone. I'm your host today, Nader Kaizat, the iOS practice discipline lead for InRhythm. And let me start by thanking you all for joining today for another exciting lightning talk with one of our own iOS engineers, Hamid, where he's going to be sharing his thought leadership surrounding the system design in iOS, where he's going to talk about where it is, what designs to consider, and its importance. And without taking more of Hamid's uh, start, the floor is yours.
Hi, Nader. Thanks for the intro. Hi, everyone. Hamid here once again uh, with another lightning talk as usual. So today's topic is different, and there are very few resources available for this topic, I would say, online, especially for the mobile, which really kicked me off to bring it up and just to share my knowledge, share my experiences, and how we can definitely achieve better system design in iOS. System design. In iOS, I would be more specific for iOS. There are a lot of resources available for the backend development, backend systems, backend applications, but I will more focus on iOS only here. What is system design? First thing, whenever we build a software, first thing we need is a design. And to architect a design, we have to combine multiple components so that we can get a design up to the mark that is enterprise ready, that can scale, that actually is more clear to the technical stakeholders or to any business stakeholders involved in the project, in software, or anything. The system design is a process of architecturing your software or system, including many components. Interface, UI is one component, data is the second component, and then you have many other components in play, which includes your third-party integrations, your requirements, and a lot of all that kind of stuff. So if you need to satisfy any specific requirements while creating a software architecture, it's important to create a system design up to the mark for that software that you're building. Now, software is definitely a complicated process of getting your business. It's a complicated tool, I would say, that is being built to get your business done through online apps, making front-end applications, or even backend systems. Possible components, what you can include in a system design. Again, I would be more specific for iOS here. And since all kind of mobile development is front end, let me give this overview first, that when we discuss system design, usually people are thinking that we're going to discuss something back end, databases, service layer, something like that. But in this lightning talk, I will be strictly focusing on the front-end based system design for iOS apps. Things that comes in play while developing mobile apps, specifically, I will be focusing iOS, but in general, you can take this into another. You can consider these components when you're building any other type of apps, including Android, Windows-based mobile apps, or any other operating system based. First component is UI components, which are normally the views that we consider. Second is the business logic. Business logic is also the part of the view models. You can call them view models as well, since your data flows from your models, from your view models to views, view models, from views back to view models. That's why you define all of your business logic inside the view models based on the modern patterns we have. Then you have data models. Data models are more specific to the data. You basically include your data models in your view models so you can deliver your data to your views. Fourth, networking, most important piece. We normally call it service layer as well. And when you architecture or design your mobile apps, iOS apps, you have a completely whole dedicated layer that you call a service layer. I usually call it networking layer as well. It's the same thing. Then off of these layers, you also have the local storage. If you're storing anything locally, it can be any sort of technology you can use. You can use existing that Apple offers or iOS platform offers, shared preferences. You can use core data. You can use cache for temporarily storing any kind of information in the disk or any kind of local storage that's available for the iOS platform would be considered as a local storage. So now these 5 components are the main components as per my research and as per my experience that we should consider while building a possible system design for your iOS-based applications. Things to consider. Now that we have all these system design components in play, we have that in mind and we are moving towards just creating a system design. What are the things we should consider with all that layer stuff, having those component-based mindset? We must consider first thing is architectural patterns. So usually people get confused with architectural patterns and design patterns. I'm going to highlight them here. So architectural patterns are more more architecture based. I would say when you design a system, the first thing comes is architecture. Architecture is usually divided in form of layers, I would say. Modern patterns that are commonly being used is MVVM, MVC, Viper, and there are many more as well. I have commonly used MVVM. I'm lately using MVVM in my modern Swift UI-based applications. So I can definitely give a better overview of that with the modern trends. Then design patterns. Design patterns are the patterns that supports the architectural pattern. Design patterns normally include singletons, factory method, observer patterns, etc. Each and every design pattern has its own use case. For example, if you're building something reactive-based, a notification-based system, you would go for observer pattern. Something you're building up more like object creation, you will go for factory method. And similarly, there's a singleton as well. So each and every pattern supports your architecture. With architecture patterns, you indulge your design patterns to make sure that you have a suitable and required system design ready for your enterprise-based applications. Then there's another thing that must be considered, especially when it comes to monolithic large code bases, or you're building even something from scratch, and that's something you want to scale, and that is modularization. Modularization, I will come to the benefits of modularization later on, but it's one of the key and very, very important piece that any system designer should consider. Either you're building a new project from scratch, a new software from scratch, or you have a legacy code base, monolithic code base, everything all together in one code base, and you want to break it into different pieces. That's where you will utilize your skills of modularization. Modularization in iOS can be achieved in many ways, but you need a support of the dependency management tools that already exist in iOS eco-based system. I commonly use pods, very common CocoaPods. It's basically the platform on which these pods are based. So I use pods to have multiple modularized components of a largely scaled project and integrate them using any dependency management tool. Pod, then you can also use Swift Package Manager. Swift Package Manager is now commonly used in the modern trends because Apple has adopted it to a very level now, and I think I would recommend that as well. And there used to be Carthage as well. I have not used Carthage much, but that's one of the dependency management tools as well that you can use. Then you also have to consider the API support. When you're designing a software, an iOS application especially, you must consider the native API support. Native API support with the modern trends and with the up to the modern trend we have right now for UI components is Swift UI. UI Kit is still being used, but if you wanna stick to the modern and updated technology trends in iOS iOS ecosystem for building UI components, then go for Swift UI. Combine is a reactive programming based framework. Again, it's native API support given from Apple. Before this, different engineers were using different technologies. There were a few reactive based frameworks. RX Swift. There was one framework that was being used, which is a third party framework. And now we have a combined, so we don't need RX Swift. Async await is a mechanism to make your network calls to the network or to achieve any kind of concurrency in your iOS applications. It can be performing any kind of task, even locally, not only the network calls. Like multi-threading, like achieving multi-threading through async await is one of the best examples. Getting your job done, job done using an asynchronous approach. Core data. Core data is again a framework available. You can it's a query based structured that iOS ecosystem. It's a native API from Apple. It's a query based structure that you can use to basically structure your data locally and store it locally. Again, I'm not used it lately, but it can be used based on whatever the requirements you have in your project. So API support, in short, adopt the native API support you have, and avoid any third-party frameworks as much as possible. If you need scalable system design and something that is more clear, something that you can degrade, something that you can upgrade time to time. Next, system design importance, enterprise apps. I have specified enterprise apps here because whenever any stakeholders are putting their money into any kind of projects, building softwares, hiring resources, spending a lot of money to build a robust software system, then your system design is very, very important, and that comes into the play. That's the first thing that any software designer, software developer would consider. Scalable solution. If you have a good system design from scratch being built, that's always going to be scalable. As I mentioned in my previous slide, modularization is one piece that's very important. So if you have a modularized based architecture, all your features are separately modularized, it's going to be easy for you to scale them, degrade them, remove them, or descale them. Anything you want to do with every piece individually, that's what's going to make your system very, very scalable. Overall system design. Documentation. So if you have a good system design, you can maintain all the pieces of your software very well by documenting them separately. That's another importance that system design definitely holds. Technical debt, a very common discussion that we always do. What is technical debt? So adopting a suboptimal approach or adopting an easy solution to solve a problem instead of choosing an optimal solution to get a problem solved, would call a technical debt. Now, I would explain a little bit more. If you want to get a problem solved, and you're adopting, and you want to get it done in 2-3 days while you're adopting an easy solution, and you know that your solution won't be optimal, then in long term, you have to replace your solution with something better, something that is more optimal, such as any kind of algorithm, any kind of program you wrote that you think needs a performance optimization. Later on in future, you have to spend more time to improve it, put more money in, put more resources in. Eventually, I would say you have in your present, you have a technical debt that you have to get rid in future. So that's what the technical debt is. If you look at the diagram I'm showing right now on the screen, the more technical debt, the more undone work you have, the more technical debt you are having in your whole software design or software development. It eventually increases your software costs in long term. The short term, you can get your work done, get the results you want, but software always scales. So that's important to consider technical debt while designing your system. Maintainability. If your software is scalable, well documented, definitely it's more maintainable. Clean code, better system architecture, you have used good design patterns, architectural patterns, eventually your software is more maintainable. Then you just build something for the short-term approach and having a suboptimal approach or suboptimal solution. Intuitiveness and clarity. So when you build a better system design, all your resources that you're involving, including devs, any other stakeholders that try to understand your system design, it would be more clear for them to get to just simply understand it without getting too much into the details of your software architecture. That's another importance. Easy integration. When you have a very large scale application, you modularize it, and when you modularize it, you need integrations as well. So that's another importance. If your system design is architecture really well, you would have easy integrations. And also, if your system is designed well, it's definitely going to have easy third-party integrations as well. So two types of integrations. First, you're going to have your own native integrations of your own pieces, and second is the third-party integrations. So that's another importance for the system design in iOS. Moving next to I've prepared this architectural diagram by myself, just by visualizing what kind of pieces I can connect here for one of the small system off of a big large scale application. So social media, it's a social media feed diagram that help you to understand how the system design works, or what the system design is, and how all the pieces are connected in the system design. I have separated two layers. One is the backend. I'm not going to talk anything about the backend because the primary focus is the front end, but I've separated this so all the audience can understand like what's coming from the backend and what's in the front end. So I have a backend which has a backend API and other notification service, third-party service, Firebase, anything you can use. Then you have a CDN, which is giving you your data. It can be images or any kind of data. On the front end, if you look at the bottom piece, the second piece basically of this diagram picture, you have API service, as I discussed, API layer, as I discussed, network layer or API service layer is the same thing. You have data coming from your backend to your API service layer. Then you have data repository layers where you're basically handling some of your data logic or doing some manipulations related to your data. And then you have persistence. So as I discussed, as I told already, that persistence is something comes on the need basis. It's possible that you're not persisting anything, and it's possible that you're persisting a lot of stuff. So persistence is one piece. You can consider it. You may not consider it based on what requirements you have. API service to the data repository and to the dependency injection. So dependency injection object graph is basically a dependency injection graph. That's an approach to provide an outside object and resolve the dependency. It's another whole lot of the discussion, but dependency injection is one of the mechanisms. You can look into that in detail, what dependency injection is. You can have this approach to make your design more robust and more scalable. Now, if I go into the apps feed management module, that's where you have the UI component, your post, anything you post on your social media that has a UI component. Your UI component talks to your view model layer. As I told, in MVVM model base, we have a view model layer where you have the business logic, any kind of manipulation related to your UI is being done here, and then that logic transfers the data to your UI. So yeah, you can scale it. This application definitely can be scaled. If you look at the social media, there are a lot of connecting pieces, but just because based on the scope of the lightning talk, I have limit this diagram to only one piece, which is a post feed coming from the back end, and how the data is flowing between different components, and then you get feed displayed on your UI. So yeah, that's one of the system design diagrams for a social media post feed. So yeah, that's all from my side. Any questions?
Yeah, thanks, Hamid, for that. And just to kind of add on one thing, we do need to have, like a good balance between the business and creating functionality and maintaining the application. But what you were talking about is how to build the right infrastructure and the right system design. So thank you for that. And if there's any, I know that it was a little bit of a high level, So if there's any interest in any of the specific topics that Hamid talked about to do a deeper dive, don't hesitate to mention it in the comments, and we can do one of our lightning talks on those topics.
Yeah, system design is a very, very huge topic. You can bring up like 50 systems and just build them like post feet. So yeah.
Well, Hamid, thank you for this. Sorry, was there someone saying anything? Okay. Yeah, Hamid, thank you for that. And then, so don't forget to join us every Thursday at 5:15 for another lightning talk where we show our thought leadership across different platform, iOS, Android, web, and backend. And next Thursday, we're excited with our Android discipline, where they're going to be talking about accessibility in Android. So don't forget to join us next week, Thursday, 5:15 Eastern Time. And with that, enjoy the rest of the day and the rest of the week. Thank you.